So in this video, we're going to talk about how to solve systems still by elimination, but this time we're going to solve them and we have to scale both equations. We have to multiply both equations. So our first step is to make sure everything's lined up, which it is. I have my x's lined up, my y's lined up, my numbers lined up, and our equal signs lined up. That's probably the most important to start with, actually, is make sure those are lined up first. And then when I go to multiply, there's just nothing that I can think of that's not a fraction. I don't want to do fractions. No one wants to do that. I mean, yuck. Nothing I can multiply 3x by to make it be 5x, or vice versa. There's nothing I can multiply 5x by that's not a fraction to make 3x. That's gross. Same thing with 9 and 4. There's not just one number I can multiply the 4 by to make 9, or the 9 by to make 4. So I'm going to use the strategy to multiply both equations. So the first thing I'm going to do is I'm going to just do the first term. I'm going to look at only x. You could look at y. It doesn't really matter. But I'm going to look at x on this first one. And I see that this this top x term has a coefficient of 5, and that bottom one has a coefficient of 3. And I'm going to use the strategy we use when we make common denominators for fractions. And if 5 and 3 were the denominator, to make a common denominator, multiply the one by the opposite one. So we're going to multiply this one by a 3, but I'm going to multiply by a negative 3. Because I know one has to end up being negative to cancel out. And I usually do the top one just so I don't forget, but you could have done the bottom one by negative instead. And then I'm going to multiply this one by 5. So basically, I multiplied a 3 by 5, and a 5 by a 3, a negative 3, so that it's going to be opposite. So for instance, on this top one, when I multiply by negative 3, I get negative 15x. And on the bottom one, when I multiply by 5, I get positive 15x. So when I add, these will cancel. Negative 15x and positive 15x cancel. Now, I can't forget to do the whole thing. When I multiply by negative 5, or positive 5, I get negative 45y equals, and then again, you got to multiply everything, including that, 18. Some people tend to forget that one. That's a negative 90. I'm going to go back up and do my top one. I multiply, and I get negative 12x. And positive 90. Okay, so when I add these together, these guys eliminate, they cancel. So we multiplied both equations this time to eliminate one set of like terms. So now when we add, those like terms do cancel. We get rid of a variable. Once we have one variable, algebra is easy to solve, or fairly. Now I get negative 57y when I add equals negative 90 plus 90, positive 90, negative 90, make 0. So when I divide to solve, I get y equals 0. Sorry, excuse me. It's the morning and my voice is still scratchy, I guess. So now I've got my y. We've solved for that remaining variable that we had after we eliminated the x. Y is left. I got y equals 0. Now substitute into either equation. I'm just going to choose the bottom one here just because it's close. No other reason. I always like getting 0 for my answer because it's super easy, because what's 9 times 0? It's 0. I don't even need to look at that. Equals negative 18. So now I have 3x equals negative 18. Divide both sides by 3, and I get negative 6. So now I have my answer. I just have to put it all together. Remember, this is one big answer. X is negative 6. Y is 0. It means the point on the graph where they both lines intersect. So it is important that you actually write them together. They're not two separate answers. It's one answer that is one point on a graph. So you need to put them together as one answer. And no, it's not okay to just circle x and y equals. You need to put it together as one point. All right, so in this next one, step number 1 of moving terms is not already done. So I noticed that this first one starts with y. I usually like to start with x because that's standard form. I guess there's no real reason it has to be the x first, but it is considered standard form. So I'm going to rearrange that first equation, and I am going to rewrite the second equation. No, don't be lazy. Rewrite it. You write a whole system together. They stay together, so when you write one again, you write the other again. You never just rewrite one of them if you want to do math properly. Okay, I need that bracket gone so that I can write. Now, I notice again that there's not something I can multiply one by that the other is. Now, I did the x's on the last one. Just because I did the x's on the last one, I'm going to try to eliminate the y's on this one. You could do the x's. I'm just choosing to do the y's this time. I could have chosen to multiply by 9 and 4 over here. I did not. So on this one, I'm going to try to eliminate the y's. So I have a 5 here and a 6 here. So I'm going to multiply by the opposite. I'm going to multiply that one by 6, and I'm going to multiply this one by 5. Now, if I do that, that one's going to be positive 30 and positive 30. That's not going to eliminate. So one of those that I multiply by has to be negative. So I end up with opposite answers. Just because it doesn't matter which one you multiply by a negative, I'm going to do the bottom one this time so you can see that it doesn't matter if it's the top or the bottom. Okay, so now when I multiply everything by 6, I get negative 30x plus 30y equals negative 150. Now when I distribute this negative 5, be careful with your signs, that's going to be positive 15, because negative times a negative makes positive, positive 15x. And negative 5 times positive 6 is negative 30y, which is good because that's what we want to eliminate those y's. And then we get negative 15. Okay, now we multiplied both equations this time. I chose to eliminate the y's. You could have chosen to eliminate the x's. It just depends. As a matter of fact, some people do this twice. I think that's a little bit crazy, but it seems like extra work to me. And then they eliminate the x, and then they do it again, and they eliminate the y. But whatever, that's up to you. To each their own. Now we're going to add. So let's add these two equations together. All right, I think I want green. All right, so when I add these two equations together, negative 30x plus 15x is negative 15x. The positive 30y minus 30y cancels. One is positive, one's negative. They are opposites, they cancel. And this is negative 165 for x. Now when we divide, x is equal to 11. And so when you get x is equal to 11, now we've got that. We solved for our remaining variable after we eliminated the y's. That's what's called elimination. We eliminate one. We find the other one. Now substitute into either equation. I'm going to move my screen up, so sorry if this disconcerts you a little. Now I'm going to substitute into the bottom equation, only this time because simply the numbers are smaller. So I'm going to multiply negative 3 times, because negative 3, 6, and 3 are smaller than 5, 5, and 25, negative 25. So that's the only reason. It might be silly because it's easier to multiply by 5s. I don't know. So now I get negative 33 plus 6y equals 3. Notice I put that x in here because that's an x value. I need to put it in where x is. So now I get 6y when I add 33 to both sides. I get 36. So hey, y is nice and easy also. Y equals 6. So remember, you're not done until you put your answer all together as one answer, because it's not two answers. It's not two separate answers. You've solved for one answer for both things together. It's one point where things cross on the graph, or the two lines cross on the graph. It could be two curves. That's why I said things. We're not ready for that yet. We're in Algebra 1, not Algebra 2. So there you have it. You have 1 point where these cross. X is 11 and y is 6. You should check them in both equations, which I quickly did. So I think we are good to go with this. All right. All right, just like when you solve by graphs or by substitution, you can get weird answers. So there are two weird answers you can get: no solutions or many solutions. And remember, you get many solutions when on a graph, when the lines coincide, when they're right on top of each other, they're overlapping. And on a graph, if they're parallel, that's when no solutions happens. They never cross. They never have a point that they intersect or they have in common. In algebra, when you're solving by algebra, like substitution or elimination, you get something really crazy, like 8 equals 12. Okay, yeah, 8 never equals 12. All the variables go away. When all the variables go away and you get a ridiculous answer, like 8 is equal to 12, 8 is not equal to 12, then it's not true. It's false, and there are no solutions. You get something weirdly false with no variables in it. And with parallel, coincident lines where they're right on top of each other and you get infinitely many solutions because those lines intersect, well, everywhere, you get like 8 equals 8 or 0 equals 0. And so you get something completely true, meaning it works all the darn time, and so it's always true. Every point on the line works in both lines. So what does that look like? Well, in this first one here, looks like I need to multiply both equations by something. So I'm going to multiply the top one by 2 and the bottom one by 3. I notice I do get a negative 6x on top and a positive on the bottom, so I don't need to do a negative this time. Yes, it's important to always write on that little arrow that you're drawing the number you're multiplying by, so the person who's reading what you're doing knows what you did. You know, your poor teacher who's trying to figure out what you did. Multiply by 2, multiply by 2, and multiply by 2. Don't forget to multiply every single term. Okay, and now I'm going to multiply this bottom by 3. I get 6x. Notice one is positive, one is negative. Negative 6x and positive 6x. Yay, that's good. They're going to cancel. They're going to eliminate. Plus 6y equals 3 times 14 is 42. Okay, and when I go to do my elimination, okay, good, my 6's eliminate, my negative 6x plus 6x eliminate, perfect, that's 0 x's, and then negative 6y plus 6y eliminate, uh-oh. Well, let's do this side, I know that one is easier, so that's negative 24 on that side, I'm good there. But what do you do on this side? I'm going to write, I don't know why I decided yellow was a good color on white, there we go. What happens when you have 0 x's plus 0 y's? What's that side? You get 0. Everything eliminated. Nothing is left. There's 0 there. There's something there, but it's a 0. Okay, 0 things are there, and you have to write 0 to hold that place value, right? We've learned from kindergarten 0 is a placeholder. Like if you write 10 and you didn't write the 0, it would mean something different. It would mean 1. You have to hold the place of the 1's place. Those are not equal. We get a false answer. That means there's no solutions here. There's nowhere. No, I'm going to only write half the answer there. No solutions. No solutions. There's not an answer to this problem. There's no place they intersect because the lines are parallel. All right, over here, we have to rearrange a bit. This first equation is in proper standard form. The second one isn't, so I'm going to rearrange so that y value is first. Now notice, it's a negative 5x, so the negative has to come with it. My 6 only half showed up. Let me fix that. All right, now I notice I have to multiply the equations by something. Looks like I'm going to multiply the top one. I'm going to multiply that by 5, and this bottom one, I'm going to multiply it by 2. I did the opposite number. Now, 1's already negative, so I don't have to worry about that. I get 10x plus 40y equals 30. So I multiplied every single one. Now, I paused a minute to fix that, so if it blinked on your screen, it was just because I fixed something. Okay, and this bottom one's negative 10x minus 40y. Oh, looks like they're both going to eliminate again. Big surprise. Equals negative 30. Okay, so now I have negative 10x minus 10x, that's 0. I have negative 40 and positive 40 is y, that's 0. And 30 and negative 30. That one of them is negative 30, the bottom one is negative 30, so it's also 0. On this side I have 0, on this side is 0. That's completely true. Hey, that's many solutions. These must be coincident lines. It's a coincidence that they're on top of each other. Coincident, coincide, and coincident. They come from each other. Many solutions. Okay, and that's going to be the answer. You're going to find that little button on GMM underneath the problem if you get so far as to do that extend assignment. We're going to skip these next few. If you would like to look in our notes, I've done them in the notes online, and you can copy them there if you need a few extra examples. I just wanted to go over a few word problems and remind you how to write word problems. All we're going to do on the homework is write the system, and then you can solve them on GMM if you get that far. All right, so my friend Frank purchased 13 Boondins and Jeffspools for about $56. Boondins for $2 and Jeffspools for $7. Now, I wanted to specifically go over this one because it's a little weird. The Boondins which are X, and the decimals are Y, boundins for $2 each, plus decimals for $7 each, is equal to $56. They kind of mixed the two sentences and the numbers together before. They didn't do that. And the next thing is you have to have a second equation for a system. He purchased 13 boundins and decimals total. He did the $56, but that had to do with this money stuff, so that's already done. Boundins and decimals is 13, so that's just a little different wording than we've had before. Now, I would solve this one by elimination, but you could easily do substitution on this one. We're not going to actually solve it. We're just going to go through writing it for saving time on our video here, because I'm sure you're done listening to me. We both, farmers Frelm and Algebra, both bought Orksteads. I never can say that one. And Mimstoons for their farms. Frelm bought 3 Orksteads and 10 Mimstoons for that much, and Algebra bought 12 and 5 for that much. So the system of equations, 3 Orksteads plus 10 Mimstoons equals $958, and that's for Mr. Frelm. And Albert, well, she bought 12 Orksteads and 5 Mimstoons for 14. See, I have problems with those two. For that much money. And so those are the two equations. And you can solve this one. I would definitely solve by elimination. I see that I have all those numbers in front of every X and Y, and it doesn't look like a fun substitution problem. So I'll have the rest written online so you can look at those notes and you can just see what they are. But your point on your homework is just to write the system of equations that matches with that word problem. If you'd like to solve it as in a little enrichment problem, I'm very willing to grade your work, but you only have to write the equations this time. All right, so that should be the end of our videos for these sections. Good luck, and make sure you let either Mr. Passford or I know if you have any questions. We'd be glad to answer them. Remember, we have Google Meets. You can do that, or email us. We're more than happy to help you out.